Hi, welcome to the final sprint progress report. I'll go ahead and launch right in. So the way I'm planning on doing this is I'll probably put all the separate videos into one large video file, but I will be editing them together. So I got a tractor mode shown here. You can see that the letters block the shooting of the bullets, and the centipede also bounces off of it properly. So you also saw that it correctly died and reset. So there are still some issues with Centipede, the head getting misplaced when a new head is promoted, but it's a lot better than it used to be because now the head starts off centered, as you can see, and the Centipede bodies will always stay in their proper location rather than getting all jittered up like they used to. So I'll go ahead and start one player mode now. You should be able to hear the sound. Once again, I should have it quiet enough that you should be able to hear me fine. I'll go ahead and do some various things, show you can't move through mushrooms, there's a spider, and I'll go for wave progression, hopefully all the way to the third wave, but at the very least to the second, because that's where Flea, shown here, and Scorpion are both implemented. You also saw the mushroom region, thanks to me dying. Bam! Yay! So that's the flea speeding up when it gets hit. One more time, or I'll just die. And I'm hoping that that a scorpion will be able to make poison mushrooms, but it doesn't, yeah, it's not looking like that's gonna happen. So I'll let him make some, hopefully end this centipede here, and the next one should bounce off. Alright, I can't even die because I don't have enough life. I'll show it in two-player mode. So this is the third wave. You can see that the speeds are all significantly faster. And that's my last wave, so after that it resets. Oh, there we go. Yeah, see, here's the centipede. There's that. Alright, and I'll go ahead and put in my initials. And there we go. Now it is up at the top. Alright, so I've gone ahead and turned off sound now. You should have a decent idea of everything. I'm going to do a more in-depth look at the score display to demonstrate that is in fact working correctly. So first off, I'll go for a medium level score. I'll just go for a bit and then hopefully that should be enough. I'll wait for the spider to come back and then die. Alright, so about 20 points, that should be a decent midpoint. So I'll just title that mid. So, goes to the top correctly, launch again, this time get a single point, and then we'll repeat the process. Title that one low. It goes below mid but above everything else as it should. And last but not least, I'll go for a decently high score. So I'll just do that by shooting the spider for a solid 300 points. And wait for, yeah, there we go. And I'll die a couple more times and show you that. HI. So, yep, goes to the top, and in addition to that, you can also see that high score does work with less than 3 letters if you really want to. So, last but not least, I will launch in 2-player mode to show you how that works, and then that should be everything, because you've seen all the critters by now, the attractor ship does have to be alive in order to go into the other modes. That's just a flaw of the way I designed it, because the ship's what takes the input. Oh well. Alright, so you can see the left score incrementing. Oh darn, I died. So, new thing. my right score now implements. Different mushroom field, that's what I was trying to say earlier. You'll also notice the high score at the top is the same as the high score from that first round. That always stays the same until that score is beaten, which I just did. So, die. And there we go. That's enough of that. Whoever gets the high score out of those two is the one who gets to put their name in. The other one doesn't get anything. So that's just... I don't know if that's the way it works in the game. I don't think the sprint clarified what to do in a situation where both players hypothetically are high enough to get on the high scoreboard, but this is the way I did it. So there we go, and now that goes to the top. Alright, so for this first code session, I'm going to look at the ships, the bullets, and the player class, which is separate from the ship. So, first things first, factories for everything important. Here's the bullet factory. Registers to current scene, sets external management to recycle bullet. Same thing with the ship factory. There's only ever going to be one of these on the screen at a time, but at the same time it minimizes news and deletes, so it's still good to have. Same thing with the player explosion factory, for when the player dies, the big explosion that happens. And same thing. So, I'll go ahead and look at the ship code first. So, here are all my functions, all my collisions, and not too many get sets on this one. These are the only ones I'm using. So I'll look at the ship.c++ now to show you the update. So single if statement to check if I'm firing based on my ship strategy. That's something I need to do every frame because of attract mode. So that's that. They can't really help that. Same with the clams. That's to keep me in my position. So yeah, here's how the fire function works. Is I just check if I can fire, and then if I can, I fire. So the ship and the bullet actually is my first example of this strategy pattern as well. Because, looking at the bullet function, it keeps a pointer to the ship, registers that, and then when it dies, it updates to the ship and says, hey, you're allowed to fire again. So, and there's the there's a deregister collision, but in addition to that, I believe that allowing fire also sets the ship to, it sets the ship to be allowed to fire again. So essentially it just says that, yeah, you're allowed to go. Also, looking at the bullet.c++ is that one's update. Another singular if check to see if I'm out of frame, to determine whether or not I should die. Again, there's really nothing to do about that one. So, here are my ship strategies. I'll pull it up right now. So here's base controls, which is for when the player is playing. I just have checks to see what buttons are being pressed and increment position by that, and then return it. That's a series of if statements, but you only need to do that when it's the base controls. The track controls, same thing, pretty much. A series of if statements to check what direction it's supposed to be going based off of horizontal and vertical directions, and once it reaches a certain limit, it'll switch those variables and start moving in the other direction. It also changes direction if it collides with a mushroom. So, this is my player class. It's a series of variables that every player should have: how much score it has, how many lives it has, and the wave. I will show you where those are set in a moment, but for now I want to look at the strategies for the players, because there's a one-player strategy, which sets the next active player always to the same player. That's for when you're only playing with one person, because you can keep playing with the same player for obvious reasons. Two-player strategy, much bigger, because you have to actually check whether or not you're supposed to move to the other player. And both of these also allow for the possibility of dying. Then they will change scene to level congrats, which will then also change to the AI level when it's finished. And the attract strategy, even more simple, because it literally just returns the attract ship every single time. Doesn't need to do any separate checks, because setting one-player or two-player mode is done in the ship. And last but not least, here's my player controller. It's a singleton that keeps all three active players, plus a pointer to which one it should currently be updating, as well as its own strategy, which I showed you earlier. A one-player strategy, a two-player strategy, and an attract strategy. Those are always generated when the player controller is created, and they're only destroyed when it is deleted. So no inefficient recreation of commands there. Yeah, so the get and next active players are the important ones here. Well, actually, that's not true. The prive strategy is actually also important. So essentially, when I start a game, I will set everything, including this, to use the proper mode, like 1, 2, or 3 player. So case 1, 1-player mode, case 2, 2-player mode, case 3, attract mode. And I do, obviously here I'm using numbers, but I do clarify with a comment in the original call to this function that 1, 2, and 3 represent 1-player, 2-player, and attract mode, respectively. And then get active player, pretty obvious. Next active player, it just uses the strategy to determine what player to use next. Here I'm going to look at the Centipede objects. First I'll show you my base class called Centipede. It has all the functions that are used by both the head and the body. So it has a constructor, it has a set state, a draw, collision, send score, and the kill function. So what the kill function does is it checks where to set the mushroom. It tries to set it ahead of where it's currently moving if possible. If it's turning, that's not possible, so it just sets it at the current position. And then it says to the next part of the centipede to promote to head if possible. Then it clears both the head and the body at the current node and explodes. The explode function is actually a function shared between all critter classes. I will show that later. In fact, I will open the .h file to show you real quick that Centipede actually is a subclass of enemy, not of game object, although enemy is a subclass of game object. Back to this, so first things first, Centipede head. It has its own subconstructor where it sets its own score command, as well as its sprite. An initialize function where it sets all the relevant variables, and then initialize values is a special function that I have, essentially just to do multiple set functions in one go, so that I don't have to call like 3 functions in a row. The update, as clean as I could get it, I just so I update the sprite. What this is doing is I'm taking a current offset and a max offset, with the max offset being up from current offset based on the value of speed shown there, and then I just increment through every step of the offset array for that frame. And then if current offset's bigger than the total offset, all of which are set in the constructor, by the way, then it'll reset the values, update the list, and change its state. So this should happen every 32 steps divided by the current speed. So the initialize list is a special function where it just sets its own state to be the state, or its own offset array to be the offset array of every centipede body behind it. And the update list does the same thing, but each of these calls a special function in Centipede body that I will show you later. And then update sprite, it's just passing in an integer, which is clarified in the main function, and then it uses that integer to determine what sprite to be. So here is the body. Similar functions, constructor, initialize, update. It also iterates through the offset and array in the same way. It also has to check whether or not max offset is less than total offset before it moves, because when a new head is created, it will go into the update list after all of the bodies, so they can potentially get to the end of their lists before it does, in which case they just stop and wait for it to reach its correct position. That should only happen once. After that, they will continue to remain behind the head. So, and then there is also a prep for offset function that I use to say, hey, it's time for you to change to your next offset. So update sprite, same thing really. So the update and initialize offsets, so they each are recursive functions. The initialize offset just takes the offset and makes it its current one, whereas Centipede body, it sells itself to prep for offset and then sets the new offset to V, which will then get called back up here. And the important difference is it actually passes its own offset to the next one rather than whatever was passed in. And the promote to head function, this one's a doozy, so I'll just you don't want us to read off the code, so I'll try not to, but it just goes through, checks all the relevant data from the current head, and passes it to the next head, and allows it to become, or passes it to the body behind it, and allows it to become a body. So it gets its sprite index. This is to get all the the position and so forth, and passes that all in, destroys itself, and sets its node to not have a body anymore. Speaking of node, I'll show that real quick. It's a linked list set, but with a head and a body. So all of my stuff is done in one big link list. And the controller. So this is the one that gets in the sound. It gets in the wave manager data, and it creates the centipede based on that. And it has a despawn function when needed to just kill everything in the centipede linked list, and last but not least, it has some functions allowing it to spawn solo heads. It has a counter also to tell it when the wave has ended. It decrements every time a centipede head dies, or a centipede part of any sort dies, that is. And yeah, so I was trying to delete the sound, but for some reason, I don't know if it's already getting deleted elsewhere or what, but it crashes, so I just have the delete sound calls commented out for now, because, you know, if they're getting deleted somewhere, then I guess it's done. But yeah, I also iterate through and destroy the head and body of every part of the node, and then also delete the nodes. So these are some of the other functions relevant to the centipede. I have the factories for both head and body separately. They're pretty much the same as I've already shown, so I'm not going to linger too long on those. Yeah, get rid of that as well, and that. Centipede state, so this is for my finite state machine. This is the base class. No functions in it, obviously, because it's a base class. It shouldn't have any. So yeah, here's my collection of the states shown in the Centipede FSM class, and so this is to guarantee that they'll only be created once and can be passed from there. Offset collection is a similar thing that creates all of the offsets once. These are my initial ones for going down that would just go straight down. Now I have smoother ones that look like a curve. I'm not using any sort of rotation matrix for that. I'm just using numbers that make it look nice. And then I'm not going to show all 10 of the states. I'm just going to show the ones that matter. So This is the moving downward one. It checks, it goes through, checks all the relevant data. So a decent amount of if checks, but it needs to know whether or not the mushroom it hit is poisoned, whether it hit a mushroom at all, and also needs some if statements to make sure those are not null pointer, otherwise it'll crash. And then, so that's move down left. Turn down left actually has less if statements, which surprised me. It just has to check whether it can start moving or if it needs to keep turning. So the if statements are more or less a check if there's something in the way that would prevent it from moving, and then if not, it just returns the move function. And last but not least, the poison one, simplest one of all. Literally just checking, am I below a certain distance? If I am, I'm going to start moving or turning, depending on whether or not there's something in my way. Otherwise, I'm just going to keep moving down. So that's that. Next up is the mushroom. I'm starting with the factory since that's always the simplest. Pretty much the same. The only difference is an added mark for deregister class, which essentially says, hey, it's called by something else when a mushroom is destroyed, and it tells the factory to tell the controller to deregister that mushroom. Essentially, this is just a workaround, so I wouldn't need a pointer to the mushroom controller and everything that could possibly destroy mushrooms, because there are certain things, like the spider and the bullet, that can destroy mushrooms. I think I actually ended up moving all that into the mushroom class, but this, just in case, I still have this here. So, the mushroom class itself, pretty simple, sets sound and all that. Initialize, also really nothing exciting. For poison, I'm just using a boolean right now, and setting the next frame based on, just changing the frame by 4 to get it to the same position in the row below that, so that it'll be using the poison mushroom sprites instead. And I have a function to return whether it's poisoned as well. The regen, so essentially this is called by the mushroom controller. It resets the health, it resets the poison, and resets the frame. It has some special kill and, it has a special kill function to prevent it from sending a score command when killed by the spider. It just deregisters and destroys itself right from there. Let's see. Yeah, the decrement health is what would normally kill it, by sending the score command and then calling that kill function. So I do have a mushroom strategy. You can actually see in the decrement health that I'm using the strat to decrement health. Normally it just returns x minus 1, but for the blockers in the attract mode, I have an eternal strategy that will just return the same value, so the health never actually decreases. So that's how I implemented that. And the mushroom controller, this is a much more fun part. So I have the regen score command, a few different variables defined in the constructor to be used, as well as the normal and eternal strategies defined here and never changed unless it's deleted, shown here. Let's see, so yeah. I do an initial spawn where I go through an integer array and set all of the when I spawn a mushroom, I'll set that part of the array to 1 to indicate there's a mushroom here. I'll explain why in a second. The reason I'm using an integer instead of a boolean array is because 0 represents nothing, 1 represents a mushroom, and I needed 2 to represent a blocker, because if I just passed in a regular mushroom into this, when I reconstructed the mushroom array based on the integer array, or on the boolean array at that point, it would just reinitialize them as regular mushrooms and they could end up dying. So I revamped it as an integer array so that I could do that, pretty much. And then that's the save function to actually stick all of it back into the integer array from the mushroom array. So, I have a function to check whether or not there is a mushroom at a given position. To spawn a mushroom at a given position, to spawn a blocker at a given position. These are more or less the same, except this one actually overwrites, gets rid of a mushroom if there's one there already, whereas this one would just not spawn anything. And I also set the strat to eternal. Register and deregister shrooms, that's just to actually put the mushrooms that are created by the factory into the mushroom array. A poison function called by the scorpion that just sets the mushroom at a current position if it exists to poison. And then the regen function. So I have a point guard here to indicate that every 2 mushrooms should increment by 5 points, as well as the starting position. And then from there, I just call the regen 1 shroom function, which goes through, regenerates the mushroom once it finds one that can be regenerated, then sets alarm 0, and when alarm 0 runs out, that function is called again. So that's how I made it. That's how I made it so it wouldn't happen all at once. And last but not least, I have functions to change grid values to pixel values and vice versa. Alright, so now I'm going to look at all the other critters besides the centipede, which I already covered. First things first, I am going to note that I do have factories for all of them, but they're all still the same, so I'm not going to go through all of them. So the enemy class, literally, all it is a function for explode that all of the critters can call, because they all need to be able to explode. I guess in hindsight, I really could have just done this as a separate function in each of the critters, but, you know, one less function to clutter those classes up. Sorry about the siren. So yeah, I also have an enemy explosion, similar to the player explosion, also with its own factory. Again, I'm not going to go through it, and really there's not really much even to comment on. It just goes through the animation and then dies. So I'll start with the spider. So yeah, creation and initialize is just taking the values and setting them. I have a check to determine whether or not it'll start moving up or down from the start, and whether it'll start moving left or right. So in the update function, I use those to determine what direction I'm moving. I multiply by horizontal and vertical direction, which are based off of the results of those checks, and that I also use those to determine my chance of changing direction. I do have 2 separate checks. I could have done that as a finite state machine, but I was running low on time, and I feel like having done a 10-state finite state machine proves that I'm able to do so, and having an extra 2-state one while slightly more efficient, doesn't really add anything to the learning experience, in my opinion. So that's why I decided it was an okay thing to cut. So yeah, I clamp it, set the position, and I have an alarm to determine when I want to check whether or not to stop or start moving. A draw function, a kill function, which calls back to the control. So yeah, this is another example of the observer pattern, by the way, is that each critter will call back to it. It will have a pointer to its controller and call back to it when it's ready to start spawning again. And yeah, collision with the bullet. So it takes a distance from the bullet's ship and its own position to calculate what distance to send in the score distance command. Then it dies. So here's the spider controller. It just has a spawn, a despawn again for when the game controller needs to get rid of all the critters, and start alarm function, which just starts the alarm and deregisters its observer, and then creates a new one when the alarm is up. Scorpion, pretty similar process of initializing with a left or right. It does not need an up or down, since it doesn't move up or down. It also only needs to check whether it's off screen and whether or not its timer is up. So yeah, I took the poisoning off of collision and have it call the poison function of the mushroom controller at a position should be about 16 frames, I believe. Yeah, draw, kill, destroy, collision, all the same. Scorpion controller, also pretty much the same. Yeah, has a spawn, despawn, start alarm, and alarm 0. So the flea has a mushroom control, which the mushroom control can actually call the flea to spawn whenever a mushroom in the designated area is removed. So yeah, it initializes at a random column, but always at the top of the screen. It has a health bar, but it only has 2. And once the health is decremented, it'll turn off can spawn and start going faster. Then the next time it gets hit, it'll just die. So that's the speed up and stop spawning, which I did show off. Yeah, so here's the update. Have to have an if check if it's off screen. Have to have an if check to determine whether or not it's at the bottom row. It needs to stop spawning mushrooms at that point, because you cannot destroy a mushroom that is spawned in the very bottom row. I don't think the game it lets you do that either, but at any rate, it shouldn't. So I turned that off, and a timer to determine whether or not it's going to spawn a mushroom. Same process as with the scorpion, except instead of sending a poison command, it sends a spawn shroom command, and it has a random chance of doing so. Flea controller, once again, pretty much the same. Actually, this one doesn't even have a start timer or a stop timer. It just has a spawn or a despawn, and when the flea dies, it will send a spawn command. And the flea controller will try to spawn if it can. If not, then the moment another mushroom in the area is removed, then a command will be sent once more, and wash, rinse, repeat until there are few enough mushrooms in the bottom few rows that the flea can spawn. So next I'm going to look at the wave system. This is what is contained in one wave. It's all the stuff we talked about in class. So here's the wave settings. It sets each level to have all of those correct. And there are default values that are set first, just in case for some reason one of them is missing, it doesn't crash the whole game. So the way the read file works is, and you'll note, by the way, I have a breakpoint here. I will run in debug mode after changing some of the wave setting files. A, to show you that this only is called once, and B, to show you that changing these values will actually change the levels. You've already seen some of the levels change in my initial gameplay demo, but just to prove that that those aren't preset, I suppose. So, a whole bunch of if-else statements to check what my input is and put that into the correct variable. I have some flexibility on the true falses, so you can use true false, on off, yes, no, y, n. Those are the ones I have accounted for. All the variables do need to have the correct names, though. I feel like that's reasonably fair request. Yeah, so, and then a terminate and a delete of the wave manager. So let's go ahead and set some of these. I'll set centipede length to 5. I'll turn on the scorpion, and I'll turn off the spider. Start debugging. So there's the initial read of the file. I'll just press F5 to continue. Game loads up. Centipede has the correct amount of segments. Scorpion spawns. Spider does not. So, sorry about the bar, by the way. It hasn't mattered for the past few recordings, but now that I'm playing again, it does. But at any rate, I've shown you everything I need to, so I guess it doesn't really matter. I'll just X out, and there was no call to the read file function, so it was only read once, just to prove. Alright, so next up is the sound controller. So it's a singleton, sets the strategy based on whether it's an AI mode or one-player, two-player mode. Same function as with the player controller, which I know was a while ago, but it passes in an integer, 1, 2, or 3, to determine what level to move to. Those are magic numbers, but I have a comment in the initial function clarifying what those magic numbers actually do. It's the best way I could think of to do this. So, yeah, so here's my get sound command. I suppose I should talk about this now. I do have a sound once factory and a sound loop factory. However, I realized that I'm never actually passing recycle calls to those factories, and when I try to pass recycle calls, it just breaks everything. So they're kind of factories in limbo, where they're still creating the stuff, and they still have the ability to recycle stuff, but they're not recycling stuff. So, you know, that's what they're. So if you notice that and you're like, why aren't these factories doing anything? Yeah, they're only being used to create stuff right now. Work in progress, I suppose. So yeah, send sound command. It sends it to the sound strategy, which I'll show in a moment. And then the delete function does get rid of the active and inactive strategies, which are created up here. So, command sound once, play the sound, command sound loop, check whether the sound's playing. If it is, then stop it and turn off the loop. If it's not, then play it and turn on the loop. So essentially it's like an on-off switch. And that's the way I used it in all of the code. So, and last but not least, my two strategies. The sound active just executes the command. The sound inactive, I don't even have a C++ file for, because literally all it's supposed to do is nothing. So that's that. There's my execute function. Isn't it beautiful? One last thing I forgot to mention regarding the sounds. I have showed the Scorpion class already, but I'll just use it as an example for the sound purposes. So you can see here that it gets a sound command when it is created, and it will only ever need to call the sound controller once. Well, no, I shouldn't say that, but it doesn't need to use any if statements. It's a single call, a one-line call. That's what I meant by once. It will obviously need to call this function more than once, depending on when the Scorpion is created, though. Alright, so the next thing I'm going to look at is the text display. So I have the glyph, the game font, the sprite sheet. Pretty much all of these are the same as they were in the demo, so I'm not really going to go into much detail on those. One new thing is a glyph factory I implemented so that I could recycle and reuse glyphs, shown here. It's really nothing that exciting, so I'll move on. Here's the score text. So these are the HUD displays on the top left and top right for each player. So I have an update score function that is called every time the current score changes. So it doesn't need to be updated every frame, as you can see from the fact that it's not an update. So it reconstructs the glyph by taking the score, taking each digit of the score, setting the glyph, and then removing that digit from the score and repeating. So then after that, I take the number of lives and use that to compute the last few glyphs. And then it's drawn every frame. So that's that. High score text is pretty similar. Same process of iterating through the score and using that to set the glyphs. Yes, same thing with the update score and draw. So same thing, except not with lives, and it's only updated every time the actual high score changes. So that's the one in the top middle. Here's the high score controller, which actually manages all of that. So it has an array of 8 scores, an array of 8 initials, and a current score to determine the score right now. So it initializes all those. The priv update score is just what I used to actually say if the current score is less than the active score, then it'll increment and set that as the new high score. So the current score here is a variable that I use to keep track of the current high score. The reason it can't be the first score in the array is because the current score can change throughout the game, whereas the array shouldn't change. Try to update all scores. I simplified this from since last time by using an array. Iterate through to this part of the array I want to change. Change everything up to that point. Then change the actual part I want to change separately, and then pass in the initial input to initialize that in that function, which I will show you soon. A special finish function, which actually takes the input and sticks it into the array that needs to be adjusted, and then a display, and then ends display. And terminate here is just to clean up the singleton. High score display is here, so it just goes through the position, and then it takes the information, copies the initials and the score into a build score function here, which then turns into a series of glyphs, and repeats that for each of the 8 scores. And then that's about all for this. There's a draw function. So yeah, destroy function I was having some trouble with. I originally wanted to recycle the glyphs, but then Teal got cranky because apparently those glyphs were getting deleted at some point. So I tried to actually manually delete them, but it still complained. So right now I just have a delete function that's not doing anything, and it allows... I'm pretty sure that the glyphs aren't actually being deleted, so I don't know what the problem is, but at any rate, the glyphs are staying, so I might be getting memory leak there, so that is one problem I have. So yeah, the initial input is the congratulations, game over congratulations, input your initials text, and then an actual input to actually take the text that you type in, display that on screen, and then pass it back once you're done. So I always have the same problem here with the glyphs not getting deleted properly. So where's the finish function? Because I know I have a call to it in here somewhere. Yeah, here it is. So once enter is pressed, I will pass back to the finish function, given the data, and then that will be properly updated. Alright, so the last thing I have to discuss, which is not actually in the document, is the game controller and the level and the scenes. So, the game controller controls pretty much everything. It should only be defined once at the beginning and deleted at the very end. So, it initializes pretty much everything, sets all the proper targets to the active mushroom field. So the mushroom factory, the flea factory, centipede, body, all need to know that. Then, so set scene, this is a function I alluded to a couple times, where I pass in an integer, either 1, 2, or 3, that's what they represent, shown here, obviously, and then set the strategies in the sound controller and the player controller to match whatever scene I'm in. So this is the function to begin the wave. This is what happens when the player dies. Everything that spawned here now despawns, and I set a respawn time alarm. The next wave function just also despawns everything, increments wave, and then sets the alarm, sets the alarm to respawn once again. Also, restart is here for when the player dies. It should call... Oh, right, okay. So yeah, what the process is, the player dies, calls this alarm to start the regen shrooms process. Once shroom regeneration finishes, then it will call the restart function. Here's a swap field function necessary for 2-player mode. This is essentially just to keep everything that I don't want destroyed in between waves from being destroyed. I set all their external management to this function, and yeah, that's about all that I need to say on that. And then the terminate function, called from game.cpp, I did acknowledge that in one of my videos, but I'll bring it up again, is that in Teal I changed one file, 2 lines. I changed it to include game controller and to terminate game controller in the terminate game function. So it goes through all the factories, terminates them, and then marks itself for destroy. So level 1.c++, what it'll start by doing is setting the background color, having the game controller set scene, initialize all its stuff, and then start a wave. And it will also enable the this, because it's level 1, will enable the score controller to keep track of score. 2-player level also does that. The AI level doesn't, because the AI cannot place stuff into the score. All my collision test pairs, and so this, you'll probably note, looks familiar. The reason that this is necessary, despite being in the game manager's terminate function, is when everything is deleted by teal, a lot of the stuff will try to recycle, and thus will regenerate those factories, so I have to then destroy them again. And the reason that I can't just not do it in the game manager is because I have a level for the congratulations screen, and nothing is on screen for those, so I don't have all these calls, so it needs to be in the game manager instead, just in case the player decides to end the game while on that screen. And that should be everything. So I'll take all the videos I've recorded, put them all into one big video, and that'll be what you're watching now.